Okay, we're just going to give it a minute before we go ahead and get started here to let people filter in. All right, now that it's after 2, we'll go ahead and get started. So first of all, I want to say good afternoon and welcome to today's webinar, 5 tips on determining the most impactful metrics in your app. Before we get started, I want to quickly review the pace of the webinar and what you can expect from our presenters today. So first, please know that all attendee lines are muted to control for any background noise. If you have a question at any time, feel free to send it through the chat window located in the control panel. We will also leave 15 minutes at the end of the webinar for a more formal Q&A session with the presenters. We also encourage you to join the conversation using hashtag Work-centric on all of your social channels. In terms of the flow of the webinar today will be as follows. Preetam from VividCortex will present, followed by Matt from Datadog. They will then have a brief live discussion covering which methods they use to define what they consider the most valuable performance metrics, the similarities between those methods, and how focusing on different layers of a system can lead to different APM solutions. And finally, as mentioned before, we'll open the floor to Q&A where you can ask questions at any time. Keep in mind that the webinar will be recorded and made available to you via email and on demand via VividCortex.com and DatadogHQ.com within the next few days. Just to review quickly again, for those of you just joining us, welcome and thank you again for being here today. I'd like to formally introduce our speakers. So please welcome Preetam Jinka and Matt Williams. Preetam Jinka is a software engineer at VividCortex. He works on backend systems and anomaly detection during the day and hacks on storage engines and distributed systems at night. Matt Williams is the DevOps evangelist at Datadog. He is passionate about the power of monitoring and metrics to make large-scale systems stable and manageable. He tours the country speaking and writing about monitoring with Datadog, and when he's not on the road, he's coding. And with that, Preetam, I will hand the webinar over to you.
Thanks, Rachel. So again, my name is Preetam Jinka, and I'm a software engineer at VividCortex. So just to give you an introduction to what we do, VividCortex is a cloud-based SaaS application performance management platform, but it is unique in that it specifically focuses on users' databases. While there are many options for APM solutions, we see many customers overlooking what's happening in their data tier. And our goal is to provide the same highly granular visibility that people expect from the rest of their systems. By doing so, we aim to eliminate systems' most critical visibility gaps with bottom-up analysis of their databases and deep insights into queries and database metrics. We support MySQL, Postgres, along with compatible alternatives like Amazon RDS and Aurora, plus MongoDB and Redis. And with that, let me just jump into the first tip for determining the most impactful metrics in your app. So tip number 1 is to determine the work your systems are designed to perform. So before you even start thinking about metrics, you're supposed to think about what your systems are supposed to do. So VividCortex views monitoring in the following way. We believe that servers exist to do work, and database work specifically is in terms of queries. So basically, our entire monitoring system revolves around queries. So we're interested in how databases complete their work and perform these queries, and also the behavior, efficiency, and the effects of each query. Furthermore, we're also interested in how this work changes over time. And those principles are how we sort of design the tools in the platform and choose the most impactful metrics. So one of those tools that we have is adaptive fault detection, which is our feature to detect microstalls in a database. So let's talk about database stalls. A stall is a type of fault. So a stall is a short period of time when work isn't being done, and it can be as short as 1 second long. And the thing about adaptive fault detection is that there is no guesswork. So this is different from many anomaly detection systems, which may have false positives. The difference is VividCortex detects real database stalls early before they can lead to bigger outages or downtime. And we can do this with zero configuration and no fixed thresholds. So that might sound like magic, but we don't have magic. We just have secret sauce, which is we have a model. So that leads us into our second tip, which is to find a model to create relationships between metrics or describe how work is being done. So with adaptive fault detection, we use something called Little's Law. So Little's Law is something that's frequently associated with queuing theory, and it describes the relationship between concurrency, throughput, and latency. So we have this simple formula, but it provides a model to relate two separate metrics, which are throughput and concurrency. So individually, you can view throughput and concurrency separately. So throughput can be the amount of work being done per second, like requests per second or queries per second. And concurrency is the number of requests that are currently in progress. So that can be web requests in progress or queries in progress. So on their own, they're not that useful, but once you use this formula and have a model to relate them together, they can tell you a lot about how work is being done in your system. So we can do this for a lot of different databases, but for MySQL, we can do that with the following metrics. So for concurrency, we can look at the number of threads running. So in MySQL, there's one thread per query. So we can see how many threads are running with show status, and that gives us our concurrency metric. And throughput, we just look at the number of queries being completed per second. And with those two metrics and Little's Law, we can detect database stalls. So here's a screenshot coming from the VividCortex faults details page. So this is showing you details for a single fault. I just have two pictures showing different time selections over. Basically, one on the left is right before the fault, and on the right, I have a screenshot of the time selected within the fault. So on the left, you can see that MySQL concurrency is around 4. So that's 4 threads running. And below that, I see MySQL queries is at about 850. So that's 850 queries being completed per second. But on the right, during the time of that fault, which is represented by the red band, I see that MySQL concurrency jumps up to almost 230, and the number of queries being completed per second is down to 30. So there's lots of queries in progress, and fewer are being completed. So that's how we describe a stall. So we had one more metric as part of Little's Law, which is latency. So latency is more of an effect of a stall. We don't really think it's something to focus on too closely, especially in the context of a stall. And one of the reasons is that you could have slow queries and fast queries, and they're affected differently. And you can't really see a breakdown when you just have a single latency number. But here we have some latency bands. So you'll see that during the time of the fault, there's barely any activity. The total counts are pretty low. But right after the fault ends, we see that we have this huge spike in the number of queries being completed, and a bunch of them have really high latencies. So in order to get that breakdown, we just need more information. And that's why we actually look at individual queries themselves, so we can have a much more detailed view of what's going on in the database. So I really like this quote from Peter Drucker, who's a really famous management author. And the quote is, "What gets measured gets managed." And I think this is a great quote to keep in mind, especially when you think about what you're trying to monitor and what you're trying to manage. So we're talking about application performance management, and this quote just really ties everything together because we're focused on what to measure and how that could help our apps perform better. So that leads us to tip number 3, which is basically what the quote says: monitor what you want to optimize. So I think it's really important to monitor anything worth optimizing. So for example, if you're interested in, if your web app is slow and you're interested in optimizing the use of indexes to speed up your queries, then you should really be monitoring how your queries are using indexes. So that's important for two reasons. Monitoring anything worth optimizing is important for two reasons. Number one, it tells you how to focus your efforts. So in this screenshot, I'm showing you a tool in the VividCortex app called a profiler, and I'm ranking queries by missing indexes. So I'm looking at the top 5 queries based on how many times they ran without an index. So I can see immediately, if there's a query that could really use an index, it's one of these top 5. And the second reason why this is important is because you can see how your optimizations can affect performance. So for example, I see a bunch of queries here that aren't using indexes. And let's say I add an index to my table. I'd want to see if those queries are actually going to use the index later on. Maybe there's an optimization, or a query optimizer problem, and the database isn't actually using the new index. So that's one thing that I want to keep in mind. And if you didn't have these metrics, you wouldn't be able to answer those questions. And sort of related to the previous tip, I said, it's important to focus your efforts. So tip number 4 is to focus on the heavy hitters. So if you're aware of the Pareto law or the 80-20 principle, or even the power law, it basically says the majority of your resources are going to be consumed by just a few of your top elements. So what we're looking at here is the same profiler view again, except this time I'm ranking the top 10 queries by total time. So this is looking at the top 10 queries based on query execution time. And what this is showing me is how the database is spending its time in terms of executing queries. So if you can see the small percentages here, basically the top 10 queries here are taking up over 85% of the database's execution time. So if I wanted to get more performance out of my database, I'd want to look at reducing how much time is spent on these queries. And finally, of course, you could look at performance during any single period, but it's also important to see how performance changes over time. So in the previous view, I was showing you a profiler ranking over the past hour, but you might be interested, how do these things change over time? How does this compare to the previous hour? So one thing you can do is, just open up a big dashboard on a screen and just stare at this profiler over time and see how elements jump in or out of the top 10. But that might not be the best use of your time, which leads us to tip number 5, automatically detect changes. So we think it's really important to detect changes automatically so that you don't have to be staring at a screen all the time. That's useful for answering questions like what's taking up the database's time that wasn't before. So here I have a screenshot of an event that was generated because there's a new query in the top 10 ranking. So what we're doing in the back end is we're looking at basically the same profiler view and the metrics associated with that. And then whenever things jump into the top 10 that weren't there before, we create an event. So that's basically automating a bunch of the work that you would be doing manually. And similarly, it's really important to look at anomalies and changes at a very granular level. So when you're monitoring thousands of metrics or even thousands of different queries with their own dozens of metrics associated with each one, it's really important to have an automated system to tell you what's changed, so you're not there looking at a wall of charts. So we have a feature called query anomaly detection, which detects changes in a query's execution time, error rate, and throughput. And we do this by using an intelligent baselining technique. So for example, if you had a cron job that ran every hour, we would be smart enough to detect that, okay, during this hour of the day, this query tends to be running much more than usual. So we'll get rid of, we'll normalize that and get rid of those anomalies and sort of build up this baseline. So we take about 2 weeks to look at every metric from a bunch of different queries, and then we can figure out a baseline performance to see how that query behaves during different time intervals. And one thing I really want to emphasize here is this is not about detecting problems. So systems are always changing, but changes aren't necessarily bad. Again, it's important to focus on work-centric metrics and how your systems are performing their work. Anomaly detection is great, but it doesn't tell you how things are performing their work. Just because a query takes twice as long doesn't necessarily mean that it's a bad thing. It could just be because it's running more often, or maybe your tables are getting bigger and it's just slowing down because it's doing more work. So here's a screenshot showing you some anomaly and metric events, which are looking at some changes in individual queries. So here's just a summary of the top 5 tips. Number 1 is to determine the work your systems are designed to perform. So for a database, we're looking at queries, but if you have a web server, then you're looking at web requests. Number 2 is to find a model to create relationships between metrics or describe how work is being done. Number 3 is monitor what you want to optimize. Again, going back to the Peter Drucker quote, what gets measured gets managed. Number 4, focus on the heavy hitters. A lot of the optimization can be done by looking at just a few elements. And number 5, automatically detect changes. And if you need to reflect and go back to these 5 points, we have a blog post that you can look at after the webinar to get a summary of these again. And with that, I'll hand it over to Matt Williams at Datadog to share their perspective and insights.
Excellent. Well, thanks so much, Preetam. So as you've heard some great tips on how to pick the right metrics, how to think about metrics. And I want to take slightly different approach to it. We both generally agree on the kinds of metrics that we should look at, but I wanted to focus on with VividCortex, you're looking at how monitoring the database, whereas with Datadog, we're a infrastructure monitoring company. So we are looking at your entire infrastructure, not just on the database. We're not going to go as deep on the database, but we're going to look at everything. So with many of our customers sending us thousands or tens of thousands of metrics every day, it can be difficult to know what metrics to focus on. So Datadog, we're a SaaS-based infrastructure monitoring company. And we focus on that kind of modern infrastructure, and that modern infrastructure means you could have a physical box, maybe it's in a server room somewhere on premises, or it could be up in the cloud. You might have on AWS or on Azure or on Google. You could have containers that are located in virtual machines or on physical boxes locally, or up in the cloud as well using ECS and other services. You could have microservices. You could have all sorts of things that you need to monitor. And on top of all of those hosts, you want to monitor your database. You want to monitor your configuration management tools. You want to monitor your application servers and web servers and all this other stuff. And we bring in a huge amount of data every single day, a huge amount of data every day. In fact, we're processing about 1 trillion data points every day. That's 1 trillion metrics that we receive from our customers. Now, no single customer is sending us 1 trillion data points, but they are sending us thousands, tens of thousands, or more metrics well, it turns out every 10 to 15 seconds they're sending us all these metrics. That adds up to about 1 trillion per day. And we provide intelligent alerting, insightful dashboards, so you can basically have one place to go to see what's the health of your entire environment and all the different pieces involved. And as I said, we are going to monitor everything, everything that's in your environment. And I've got a bunch of logos here of different products you might be using that you might install on your systems. And it's kept, kind of small, so you can kind of recognize them, but you're not meant to read them all. But we can see all sorts of things that we monitor, whether it's Nginx or Ubuntu or MongoDB or Dyn or Flowdoc or all sorts of other things that we will collect metrics every 10 to 15 seconds and then give you these amazing dashboards. So, why do I start with a picture of the rain? Well, when you drive a car, you are typically paying attention. I hope you're paying attention to what you're doing. You're paying attention to a lot of things, basically a lot of metrics. You're paying attention to the speedometer. I hope. I hope you're paying attention to the speedometer. You're paying attention to the, how fast the rain's coming down, when did the rain start, so you know how slick the roads are. You're paying attention to the lines in the road. You're paying attention to all this stuff, and you're using that to become a better driver, to stay in the lines, to stay, at a reasonable speed, and to not hit anything. And that's kind of the point of monitoring. You're trying to pay attention to. Wow, that was weird. Sorry about that. You're paying attention to all these things. You're paying attention to everything to be able to drive efficiently. And with monitoring, you are basically doing the same thing with your infrastructure, paying attention to a lot of metrics. You might not be paying attention to all the metrics that get collected. In fact, when driving, you're not paying attention to all the metrics. You're just paying attention to a subset, the most important ones that are most important to you. But your car is paying attention to everything. And so your monitoring system is paying attention to everything that's going on, and you're looking at just a small subset. Well, one of the reasons that you do this is to figure out what is normal. What's normal for your environment? Over time, the system or you or the people that are involved with monitoring will figure out what is normal in your environment. And once you know what's normal in your environment, then you can start tweaking things and making changes. And hopefully there are going to be changes that go in the right direction. But sometimes there are changes that go in the wrong direction. But you need to know what normal is in order to know whether that change you made was good or bad. And if it's bad, okay, revert and try something else. One of the big goals of this is to give you the tools to let you make changes, experiment, and hopefully go in the right direction. And if you go in the wrong direction, be able to know that you need to revert back. And we like to think collecting data is cheap. You should be collecting as much data as you can. As I mentioned, we've got a lot of customers are sending us tens of thousands of metrics every 10 to 15 seconds. And as a service, we are storing all those on our service and making them available to you whenever you need it. So collecting data is cheap, and not having it when you need it can be really expensive. Now, what does that mean? If we go back to the example of driving a car, you've got you're collecting all this data about what's going on in the car. Every time the speedometer is being collected by the onboard computer. How many times you press the gas and how many times you press the brake is being recorded by the onboard computer. You might not be paying attention to that, but it's all being collected. And then at some point you experience some sort of problem with your car and you take it in to get fixed. If you don't have all that data about what exactly is going on, when did you brake, when did you press the accelerator, when did the engine light come on, all this stuff, it's going to be hard for your mechanic to figure out, oh, okay, here's what you need to fix, here's what we need to do. You might have to drive around the block a few times to find a problem, and maybe doesn't find a problem. So not having all that data when you need it, it could potentially be expensive. Hey, he might send you home with an unfixed car. But when it comes to monitoring your infrastructure, your systems, your computer systems and software, there are potentially a lot of metrics that you need to deal with. And you are, in the case of the car mechanic, you're the mechanic. You're the person fixing this stuff. And it's hard to know what all this stuff means. It's hard to know which of the thousands of metrics you need to pay attention to for any given application. Now, one thing that we've tried to work on, or we've definitely been working on over the last few months, is coming up with some guidance. Guidance around what metrics you should pay attention to. And we've come up with a series of blog posts called Monitoring 101, Alerting on What Matters. And I think it started out as 4 posts that just explained, when thinking about metrics, there's this kind of larger framework you can think about. of work metrics, resource metrics, and events. And if you, can we go back one slide? There's this larger thing of work and resource and events that all fit together, and that's the framework you want to use when thinking about metrics. And so the Monitoring 101 guides go through, over the course of several articles, how to think about what is a work metric? What exactly is it? How do you find a work metric? You're collecting lots of metrics. Which ones are the work ones? Which ones are the resource? And which ones are the events? So here's the kind of high-level view. There are, we have thousands of metrics, and we split them up into large buckets. And those buckets are work metrics, resource metrics, and events. The first one is work metrics. Work metrics include a bunch of different types of things like throughput and success and error and performance. All of these metrics, you'll go through all of the metrics you'll collect, and you'll find examples of all of these 4 examples: throughput, success, error, and performance. So some examples of these include, if we're dealing with Nginx or Apache, the work metrics could be requests per second. How many requests are being received by the Nginx server or Apache or HTTP? Well, there's a bunch of other ones like TP. How many requests are being received by that server every second? And then on the errors, it could be 404s. How many of those requests result in 404s? And you probably don't want to just look at the scalar value. Well, there were 1,000 404s in an hour. Well, that doesn't really tell you anything. 1,000, what was that? 1,000 out of 1,000 or 1,000 out of 10 million? So you really want to focus on that percentage. What percentage of all of your overall requests are 404s? And similarly, which ones are 200s, because you care about the successes as well. And it depends. I can't tell you what is the right number. For some people, 90% success is good, or 95 or 99% success is good. And then others, well, maybe 5% is good. That's good enough. So I can't tell you what's good, but these work metrics will help you decide what is good for your environment. The next thing are the resource metrics. Resource metrics include utilization, saturation, error, and availability. Now, utilization includes a lot of different things. Basically, how is your resource performing? What is it doing? And so one of the common examples is CPU utilization. And CPU utilization, on its own, is kind of useless. It doesn't really tell you anything on its own. You want to use this in context with the work metrics. So your work metric shows you how many requests per second, but your CPU utilization helps add a little bit more of a story to those work metrics. So if you had a throughput of, 10,000 requests per second, and your CPU utilization was at, 20%, and then all of a sudden you went down to 2 requests per second, and your utilization spiked up to 98%, that becomes a really interesting story. All of a sudden, my CPU is pegged with just 2 requests. There's something weird going on here, and that's something I can troubleshoot. But utilization alone, kind of useless. Same thing with saturation, error, and availability. So an example of saturation is queue length. Queue length, because when a resource is oversaturated, it starts to build up a queue of things that need to get done, and so that queue length helps you measure the saturation. Again, so resource metrics don't really provide a lot of value on their own, but they do provide a lot of context to the overall work metrics. The third bucket is the events. So this includes code changes and alerts and scaling events. And on their own, kind of useless. But when you put them in context with the work metrics, and even better with the resource metrics as well, they become a really interesting story. So examples could be code changes. Like a Jenkins deploy or a Git commit. So you're working with a code base. Somebody does a commit. and you see some sort of, you see an event. That commit doesn't really mean anything on its own. And then soon after that, maybe it's automated, maybe there's a human that presses a button, and Jenkins does a deploy. And when that deploy happens, well, okay, deploy happened, but it doesn't really tell you anything. But if there's that Jenkins deploy, and like 2 seconds after, or 5 seconds, or some minimal amount of time afterwards, all of a sudden throughput tanks and utilization goes way up. Huh. Well, that becomes a really interesting story. Can I definitely correlate the problem to, or can I say that the problem was caused by that code change? Well, probably not, but I can at least start my investigation down the route of looking at that code change. Okay, so those are 3 buckets that you want to split out all your metrics into, and really focus on the work metrics. In fact, you should create your most important alerts based on those work metrics, and they're really the symptoms. They're the things that you should really focus on, and everything else, well, it's important. It's definitely important to collect all that other stuff, but you use that other stuff to investigate those work metrics. So work metrics and resource metrics and events, all the other things will help you add context to the initial work metric that you were alerted to. So page on the symptoms, which are the work metrics, and investigate using everything else, all the work metrics and resource metrics and events as well. So this is not a single level. With most of our customers, they're not looking at just one thing. They're not just looking at a web server or a database server. They're looking at a larger application, and they're looking at a really large system, a collection of huge numbers of applications that are all working together. And so if you just care about your web server and you look in and you see that resources, that the request per second tanked and the CPU utilization went way up, and there was this GitHub deploy or Jenkins deploy that just happened, you've got most of the story, but maybe you start investigating and you don't really see anything that would cause this. It should all work. And so you go a level deeper. Maybe that level deeper is the database. And you look at its work metrics, and you look at its resources and its events to try to figure out, well, is there another story there? And maybe that doesn't tell you everything you need to know. And you dig a little deeper. You go maybe to the file system or to the EC2 instance, and you look at its work metrics and its work resources and its events. And you keep digging deeper until you can't go any deeper, or until you figured out the real story here and figured out what is causing the problem. And so that brings me to the end of my session. And again, I wanted to get across how we think about finding the right metrics, how we think about finding the metrics that are most important to you. Every time I do a session, somebody will say, well, just give me the 5 metrics that I need to care about, and that way I can go home and focus on that, or go back to work, focus on that, and not worry about it every day. And there's no way for me to answer. There's no way for me to tell you these are the 5 metrics, because there's no way for me to know your overall business goals. And because all the metrics that you're collecting should somehow relate to your overall business goals. And so I think at this point, Preetam, we'll kind of open it up for a little bit of a discussion.
Sure. So I have a few questions here that we can go through. I think one thing that I'm really interested in hearing more about is how each of our apps helps users find problems. So do you want to go over how Datadog helps users find problems?
Yeah. So I mean, we're going to give you, as soon as you install the agent on each of your hosts and then turn on the different integrations, we're going to give you a lot of metrics. And you're going to use those, again, you're going to look at those work metrics to find issues or problems that are going on in your environment. Yeah, maybe there's nothing going on today, but at some point in the future, you'll see some sort of problem. and you'll keep you've we provide you a lot of dashboards. As soon as you install any of the integrations, you get a dashboard along with it for free, and then when you start working with that dashboard, you realize, well, there's these two graphs I don't really care about, and there's two other graphs I wish were there, or 10 other graphs I wish was there. And so then you go in and tweak those dashboards to be exactly what's most important for you. You know, when you install one of the dashboards, like for Nginx, it's going to be totally focused on Nginx. But maybe you want to see Nginx along with some Postgres stuff, and you along with some basic EC2 metrics as well. You want to have a dashboard that completes everything, shows you everything you need to know for your business. And then you'll use that dashboard to figure out, well, what's going wrong, and you'll correlate events with metrics, and that will help you figure out what is the overall problem. What about in VividCortex?
Sure. So we do provide dashboards and events, but I think what really sets us apart is, because we're looking at individual query workloads, we try to provide, that information front and center. So we have this tool called the Profiler that I posted screenshots of, and that really lets users rank different categories of items like queries or databases or database users by many different dimensions. So you could view the top 10 queries by total execution time, or total throughput, or even the top 5 or top 10 queries by errors or missing indexes or slow queries or poor indexes. So that way we sort of emphasize, if you're interested in optimizing queries that are missing indexes, we just present it very clearly that, okay, here are the top N queries that are missing indexes, and those are the ones you should focus on first.
So those top queries, I guess is it going to present a different experience if you're using, say, Mongo versus Postgres or MySQL? Is that experience of finding those slower queries different?
Well, one view that we have is, if you select all of the different hosts in your environment, then the profiler will show you an aggregated view across the entire environment. So you can look at the top 10 queries, and you'll see sort of a scattering of, Redis queries and MySQL queries or MongoDB queries. But you can definitely, drill down and filter out things just the same way. But of course, if you rank top queries by throughput or count, I think you're definitely going to see Redis queries at the top because they're the ones that run the fastest, or they have the most frequency.
Mm-hmm.
So if you're looking at total time, which is more relevant to what the database is doing in terms of actual work and execution time, then I think that's a great way to focus your efforts.
Cool.
So let's jump into the next question. As a user, how much should I know about my systems to use each app?
Well, for Datadog, we definitely want to provide everything that our typical customers needs to be able to have a well-informed decision. Going back to that Peter Drucker quote, what you monitor is what you're going to well, what was the exact wording of it? Basically, what you monitor is what you can make better, or something like that. What was the exact wording? Oh, we're both put on the spot here. Anyway, you get the idea. We kind of remember what it generally said, and I've forgotten the question. Sorry. Oh yeah, what should we know about our systems and I think we're there to provide a lot of the information, but it's up to you to, as a user of Datadog, to go in there and use this information in the right way. We don't provide guidance within the app other than our default dashboards as to here are some metrics that we think that should apply to you, but it's really up to you to relate how those metrics how they relate to your overall business goals, because again, the business goals are what's most important, and there's no way for us to provide guidance around how your business goals apply to these key metrics. How
Yeah, I
about
agree.
for Vivid?
I think we have the same general approach. We show a lot of information that people are probably going to be interested in. We have a bunch of preset dashboards, but it's really up to the user to see, based on what they know of their databases, to see where the problems are. So, for example, if there's a query that's the top query in your environment, that may or may not be surprising to you based on your database workload. If there's something up there that you don't recognize or shouldn't be taking up too many resources, then that's up to you to optimize. But as a tool, there's only so much we can provide that you can take advantage of. But I think if you're a brand new user who doesn't know too much about databases, I think our tool does a great job to pick out the relevant information. Again, looking at missing indexes. If you're new to MySQL, you might not know, how to fetch that information. How would you know if a query is using an index or not? So we can provide that information without you having to, go and open up a shell and figure out, okay, how do I look at the explain plan or something? So we can provide that through a user interface that people can use without knowing too much about MySQL or Postgres or something like that.
Yeah, and I've actually used the Datadog interface to help me, focus my learning efforts. I want to learn about a new technology or a technology that we're using at Datadog. One of the things I'll do is look at the dashboard, figure out what are the 10 or 15 most important metrics according to who wrote the dashboard, and then I'll start researching to figure out, well, what does this really mean? Okay, I know nothing about product X, but somebody's saying that I should focus on these 15 or so metrics. Well, what do they mean? Do they count as work metrics, or are they resource metrics? And so I'll use that dashboard as that kind of jumping off point to be able to figure out what does everything mean and what should I focus on.
Yeah, I agree. I think I've had that experience before too. So if there's a problem, we just open up our dashboards, and if I see a spike in a metric, I say, okay, what is this InnoDB metric? And I can just Google it and figure out and say, oh, okay, that's what that's keeping track of, and then that's sort of my learning experience to learn more about the system that I'm monitoring.
So it sounds like we both provide opportunities for somebody to, if they're inquisitive and they want to learn about new technologies or technologies that are being used by their company. We can definitely provide, at least an initial pointer in the right places to go to, or right kinds of information to collect. How much? So I think at one point during your session, you mentioned that to get the baseline, you needed about 2 weeks of data. I guess you can get, you're using your tool before the 2-week point, right?
Yeah, absolutely. So that's mainly just for keeping track of long-term changes. So that's part of the anomaly detection service that we have in the back end. So that's looking at queries over long periods of time, over weeks or several days. But we definitely have, several other systems that look at, things 1 second at a time, like fault detection. So that starts working, as soon as you install the agent. So we have, different tools to look at problems with different timescales.
Cool.
So the next question I had was, how well do our services work with a modern microservices architecture?
Yeah, I mean, at Datadog, we like to, we collect a lot of information, and we don't really mind where that information is coming from. Really, all that's necessary is installing a Python-based agent. And now we can install that agent on a physical box. We can install that agent on a virtual machine. But when it comes to Docker, we can install that agent as a sidecar container. And once we have that on that sidecar container, we're going to collect all the metrics from all the other containers that are on that host. And so you basically install one agent in a container for each of the hosts that are hosting all your containers. Now, if your definition of microservices extends beyond just Docker and containers, extends on to more of these serverless architectures as well, then we have a solution there as well for collecting data about your application that might be running in, say, AWS Lambda. I know I've been spending a lot of time with Lambda recently, but how about on the VividCortex side?
So I think what's common to a lot of microservices is, maybe each service has its own database or a different flavor of a database. And I think what we do really well is sort of have one dashboard where you can monitor lots of different kinds of databases. So if you have a MongoDB instance for one microservice and another microservice that's using MySQL, we'll show queries from both on a single page. And of course, you can drill down and separate the two out. But to get an idea of all the queries being run on your entire data layer, I think we do a pretty good job of abstracting out the database-specific components and then just view the database work as generic queries. They don't just have to be SQL. MongoDB is a NoSQL database, but we can treat all of those in a similar way by using this idea of a query and using that as a unit of work.
Okay, so I didn't realize that. So when I open up your tool, I'll be able to see how all my database queries are doing across all the different databases I'm using, all in one dashboard or one view.
Right. So like on the summary page, you could see how many queries are being executed on every single type of database. I think at least for us, we have a lot more Redis queries, so most of that count will be attributed to Redis, but yeah, same idea.
Cool.
So that leads into my last question, which is, I guess we're more of a bottom-up monitoring solution where we're looking at the queries and then working our way up. But Datadog is more of a top-down monitoring tool. So my question was, is the top-down approach or the bottom-up approach better for a microservices architecture where you have lots of different things all over the place?
Well, I hate to take the easy way out, but I think they're both kind of right. I don't think there's any one right way to collect metrics and to look at metrics. Ideally, you want to look at it from both perspectives. There's I think ideally you're going to be using Datadog, but you're also going to be using VividCortex, and you're going to be using some other tools as well to give you a more complete view. You want to have all those different perspectives joined together to figure out, what's my environment doing right now.
Yeah, I agree. There's actually one thing that I think about, which is, so if you're monitoring a web application, you might have, one API endpoint or something that executes different queries. Maybe like 4 or 5 different queries. And if you're interested in how that app is performing, then you'd want to get more information about all of those things together. So that's what you get from the top-down approach. But on the other hand, if you use a bottom-up approach for that kind of diagnostics or problem solving, you can't really tie together those relationships again. Because you're just going to have 4 separate queries, but the bottom-up approach doesn't really have any insight into an API endpoint or whatever. But on the other hand, if you're really interested in optimizing your database workload and how your databases are performing, there's really no alternative than to use the bottom-up approach and go from the queries on up.
Cool.
So that wraps up. Go ahead.
Yeah, I guess at this point we want to switch out to any questions that the audience has.
Yeah, so we'll just give it a couple minutes to see what types of questions come in. Preetam and Matt, thank you so much. We'll just hang tight for a second, and then we'll jump right into questions. Okay, so we had a couple questions come in. I just want to mention that we only have about 7 minutes left, so we'll have to run through these. We'll pick 3 of them, and we'll have to run through them pretty quickly. So the first one that came in is, do you only monitor what you want to optimize, or do you monitor everything? So I'll let you guys handle that.
Preetam, do you want to cover?
Yeah, sure. I definitely think it's important to monitor everything. We talked about learning more from our monitoring systems, and if you just pick out certain things that you want to monitor, then you're going to miss out on all the things that you don't know about. So it's definitely important to monitor everything, and I think it's especially important to monitor the things that you're trying to optimize. Of course, there's always more metrics you can add, and sometimes it just might get too expensive to monitor millions of metrics, but you should especially try to monitor everything, and based on what you're trying to optimize, I would add on metrics that sort of reflect whatever you want to optimize.
Yeah, I mean, I think my session, my half, definitely talked about collecting everything. You should collect everything and as much as you can, and use all that information to answer whatever question you might have. You might have a question today, but you might have another question 6 months in the future that you haven't even thought of yet, and you can't answer that question unless you have all the data and you have it all available to you. And I guess there's 2 different ways of thinking about monitoring. Are we talking about monitoring your monitoring application, monitoring stuff, and collecting a lot of stuff so you can use it later on? Or are you talking about how does your human brain process all this data? And obviously, you're going to be processing a lot less data than your monitoring application. And so I think we're usually talking about the monitoring application. Yes, we should collect everything because it's got an almost unlimited brain, and so it can collect all of this stuff, and then you can use that data later on to answer your amazing question in 6 months.
Awesome, great answer. So the next question that I have is, who is the primary user of each tool, dev or ops?
So on the Datadog side, I think it's both. It's you want to start monitoring early on. You want to start monitoring and collecting metrics about your application as you're building it. One of the first things I do when I'm building an application is start turning on the monitoring. Some small piece of my application, and if I don't realize it's blowing up everything, I might go down the wrong route. And so you should be doing it early on. So that's definitely on the dev side. But most people will think of it as an ops tool as well. So it really fits for both audiences.
Yeah, I agree. I think at VividCortex, we have a lot of DBAs who use the product because they're the ones who are managing the databases, and they see a great overall view of what the database is doing, and they have a bunch of tools like explain plans that they can look at very quickly, and they don't have to have access to the database to do that work. On the other hand, a lot of devs use our tool because they're the ones writing the queries for the most part, and they can see the effects of their query without having to ask the DBA for that data.
Great, and then we only have time for one more question, so let's see. This is a good one. So these tools seem to overlap a bit. Which one should I be using?
I think we sort of covered that during the top-down or bottom-up discussion question. I think they're both pretty useful. I know we definitely have users who use our app as well as Datadog, and we have an integration with Datadog so they can send metrics to Datadog. And I think it's very valuable to have the top-down approach that Datadog offers as well as the bottom-up monitoring solution that we offer. And I think those together make a pretty good fit.
Yeah, I sometimes wish there was one tool, one tool to solve all your problems, but there isn't one tool to solve all your problems. We focus on different pieces of the puzzle. Datadog, we're focusing on your infrastructure, overall infrastructure, but we don't go into as much detail as VividCortex goes into about your database. And then there's lots of other tools that we work with as well that we just don't go into as much detail about those, and so we bring them all into Datadog to give you kind of an overall view of everything. And so you really need all these tools, and you definitely need VividCortex, you definitely need Datadog, and a few others.
Great. Well, big thank you to you, Matt and Preetam, for such a great presentation today. Just as a reminder to everyone, this webinar will be recorded and made available to you via email and on demand on vividcortex.com and datadoghq.com within the next few days. So we have come to the conclusion of today's webinar. Thank you all for joining us, and have a wonderful day.